Welcome to Alltop School Classroom. Today we're gonna explain the problem from 2021 Fall AMC 12A, question number 24. So let's take a look at the question first. Convex quadrilateral ABCD has AB equal to 18, A equals 60 degrees. That's on the bottom corner. Actually, this diagram was not provided earlier. And AB parallel to CD in some order, the length of the four sides form an arithmetic progression. And a side AB is a side over the maximum length. The length of another side is A. So that means this AB will be the bottom base. So the other side could be any of these sides, AD, DC, CB. We want to find the sum of all possible value of these AD. So that means whatever the value of these sides, AD, DC, CB, satisfying this condition, we're going to find sum of all of them. Okay, this is the multiple choice, 24, 42, 60, 66, 84. All right, the condition is very simple. Only given the bottom base, AB 18, which is the longest side. And also we have the one of the angle, bottom angle will be 60 degrees. We need to find out any possible value of the other three sides, and then we get a sum of all of them. So let's take a look. Generally, we're gonna do cutting the trapezoid into two shapes. One is a triangle, the other one gonna be parallelogram, unless this is a isosceles trapezoid. That means the two legs are equal. We're gonna do differently. We do the perpendicular line from the top two corners and then drop the perpendicular lines to the base. But for the general trapezoid, we're gonna draw a parallel line to one of the legs. So we're gonna follow this general strategy. We're gonna take a parallel line DE parallel to one of the legs BC. So these are intersecting with the point on AB on the bottom base. So certainly these will be parallelogram. So these two sides are equal. BC and DE will be equal. Okay. We're gonna label the top base as, let me just do this. The top base I'm gonna label as C. And then after you cut this one parallelogram and a triangle, the bottom base has been split into C and 18 minus C because AB equal to 18 then. We're gonna denote the other leg as D. So we have the BCD can be the value of A. For any of these can be the value of A we're looking for. Okay. So certainly in this triangle, ADE, we have three sides labeled as D, B, and 18 minus C. We have this angle 60 degrees. So the first thought will be using the law of cosine in this triangle, right? So now we're gonna do the law of cosine in this triangle, ADE on this triangle. Okay. And then in this triangle, we're gonna do D squared plus 18 minus C squared minus 2 times D times 18 minus C cosine 60 degrees equals B squared. This is standard law of cosine. And then we're gonna simplify this. The cosine 60 degrees is 1/2. So multiply by 2, cancel. We get a D times 18 minus C then. And let's just go further for this one. I'm gonna move the D to the other side. We get a B squared minus D squared. Because left-hand side, we can see 18 minus C is gonna be the common factor. We can take out for this one. And then you're gonna get 18 minus C minus D. the right side b plus d, b minus d. Make this form as a linear form, okay? So these are the main equation we're gonna use across the whole solution. These are containing the variable b, c, and d. Once we know some of the variables, we know the others. Okay, so I think the first, the very important step, just to find the relation between b, c, d using law of cosine in this triangle. Okay. All right, so this diagram basically can retire. We only use this one to find the relation. The rest of the solution will be finding the value of BCD using the condition, the three sides forming arithmetic progression. So let's go from there. Let's talk the K be the common difference for the arithmetic sequence of the side length. We usually use the common difference as a D, but we use K just because we already have the variable D. We don't want to do that. So that's why we're gonna just using this one directly, okay, for K as the common difference. Let's just try to write them out. B, C, and D will become 18 minus K. Certainly this is the longest one among the three sides. 18 minus 2K, 18 minus 3K. This is from the longest one to the shortest one in this order. We don't know which one is the longest one, which one is shortest one, but certainly they are in certain order. They can be in different arrangement. So the shortest one should be positive value. Anyway, we can find out the range of K. K has to be less than 6, cannot be going further. All right. Since AB equal to 18, so the maximum length, this is going to be the maximum length. So the longest length, 18 minus K, has to be less than or equal to 18. So the among these three sides of this A, B, C, D, the longest one, 18 minus K, will be less than or equal to 18 then, okay, like this. So we can find the lower bound of this K. So now we get a really very few value for this K value for the common difference. Okay, we're gonna K is between 0 and 6, including 0. Because even though that's the longest, the maximum length, the other side could be equal. That should be the special case for the trapezoid, right? So that means the lower bound should be including 0 as the value. Okay, K equal to 0, will become rhombus, that's still valid. So all the sides become 18 then. Okay, 18 minus K, 18 minus 2K, 18 minus 3K, they're all 18s. They're still rhombus, still satisfy the condition. So we have one of the special value for the other side A, and then that will be 18 then, possibly. And then K does not equal to 0, the BCD belong to this three value in certain order. I put in the set just because it's not really mean B is equal to 18 minus K, C equal to 18 minus 2K, D equal to 18 minus 3K. Could be any order. Okay, now we're gonna do it. They have 6 arrangement because 3 factorial arrangement for these 3 values, assigning to B, C, or D then. So let's just see the 6 cases accordingly. The first one gonna be in this order, 18 minus K, 18 minus 2K, 18 minus 3K, B, C, D. The next one can be switch these two for C and D. And then the first one can be 18 minus 2K, the other one in this order. So first one 18 minus 2K, the other one switched. The first one can be 18 minus 3K, the other two switched. The other two can be 18 minus K, 18 minus 2K. And then we switch them. You get 6 cases. We say in certain order for the arithmetic sequence. So we just try to find the value for B, C, D in these 6 cases. Some of them valid, some of them may not be. So we need to figure this out. Okay, let's do case by case. This is the relation when we do the law of cosine, we get this relationship for B, C, and D. We already factor them out, make this a little bit easier for us to do some calculation. So B, C, D, let's say they're gonna be equal to 18 minus K, 18 minus 2K, 18 minus 3K in this order. So we're gonna plug in 18 minus C, C is the middle one. So that means this will be 2K. And then the second one, 18 minus C plus D. C plus D basically is gonna be 36 minus 5K. When you do 18 minus them, you get a 5K minus 18. The right side, you can see B plus D, the first one, last one, 36 minus 4K. B minus D will be 18 minus K minus 18 minus 3K, you get a 2K. So these are gonna be very simple equation solving. We can cancel the value of K because K does not equal to 0. We can simply, cancel them out. So the leftover will be 5K minus 18 equals 36 minus 4K. So we can solve this linear equation, K equal to 6. But we know the K is gonna be in the order, K will be greater than equal to 0, less than 6. But this one, you get a K equal to 6. That's not what we want. So these are gonna be the valid case, invalid case. So that's one. Second case, we're gonna do keep the first one as it is, switch the other two, 3 and a 2, 3K, 2K. Gonna do the same thing, plug in. This will be minus C. The middle one is 3K. 18 minus C plus D, there will be 5K still, 5K minus 18. B plus D, that will be 3K. 36 minus 3K. When you minus, that's gonna be K. So we can also cross them out for this K. And we can even make this really simple, distribute it, 15K minus 54 equal to 36 minus 3K. So you can solve for this K value equal to 5. That's certainly, we know the value of K greater than equal to 0, less than 6. So this one works. Okay, that's the second one. But for this one, we're gonna calculate the value of the sides. So the value we're gonna plug in, 18 minus 5 is 13, 18 minus 15, 3, 18 minus 10, you get an 8. So you get these are 3 possible value for the other 3 sides. So they are, any of them could be the value of A, right? We said that A will be side length of the other side, any possible side of the other 3. So we're gonna just add them up for the possible sum so far. Get a 13 plus 3 plus 8, get a 24 as the possible sum. So this is only the second case works so far. We're gonna go to the third case. The B equal to 18 minus 2K. The other one gonna be minus K minus 3K. So we follow this order, subtract it, C is here, K. 18, these two add together, 36 minus 4K. 18 minus that, you're gonna have 4K minus 18. B plus D, that will be 36 minus 5K. B minus D will be K then. So you can simply cross out this K. We solve this linear equation. The K will be equal to 6, but this one still not satisfy the condition. K has to be less than 6. All right, so third case also invalid. Let's look at the fourth case. They could be, we're gonna keep this as it is and then switch the other two. follow this one, doing the same thing, plug in, we solve for the value of k, which is 2, because you can see minus c, that will be 3k. C plus d is these two, 36 minus 3, C plus d, 4k, so 18 minus 36 plus 4k minus 18. This is b plus d. B plus d would be 36 minus 3k. B minus d would be negative k. So we're going to cancel the k. So you get a 12k minus 54. This is a negative 36. This is a positive 3k. So k equal to 2. And then we're going to plug in for the 3 value. 18 minus 2 times 2, 4. So that will be 14. 18 minus 3 times 2, 6. 18 minus 6 will be 12. 18 minus 2, you get a 16. You get a 3 value for B, C, D. D can be the value for A, because A is going to be any possible value of the other 3 sides. So we're going to add them up for the possible sum in this case, 42 then. So that's the 4th case, valid. So far, the case 2 and the case 4 works. So we're going to do the 5th case. The first one, 18 minus 3k, and the other 2 are going to be 18 minus k, 18 minus 2k. We follow the same process to plugging into this equation. And we solve for the value of k, but this time still not valid because we get a k equal to 9. Because the value for k has to be in the range of 0 and 6, including 0. So these are too large. So the case 5, invalid. So let's do case 6, the last case. The first one, B, C, B is 18 minus 3k. The other one going to be switched, 18 minus 2k and 18 minus k then. So we're going to do the same calculation. You can see 18 minus 3k for B. We're going to plug in 18 minus C. C is this one. That becomes 2k. And C plus D, you get a 36 minus 3k. And then subtract it from 18. You're going to get 3k minus 18. B plus D, the first one, the last one add together, 36 minus 4k. B minus D is going to be negative 2k. So you're going to cancel the 2k. So you get a 3k minus 18 equal to 4k minus 36 because there's a negative here. So we solve for the value of k. That's 18, even too big, because k has to be less than 6. So the 6th case also failed. So far, we just finished all the cases from all the possible arrangement for the 18 minus 3k, 18 minus 2k, 18 minus k. So we only get 2 cases works. We get 2 sums so far. But the very beginning, if they are all silent, it will be all equal to 18 as a rhombus, also works. And the other case 2, we get a 24, case 3, we get invalid, case 4, we get a 42. So we get all the possible value of A for the other 3 sides. And then that's the sum as 84 then. Okay. So to this point, we're done then. Thank you for watching. Please subscribe to get a more update for the future video lesson.